Alright, so welcome again to the Nuclear Chemistry and Energy lecture series. So this is part 2 of the lecture. Okay, so I want you to remember this symbol notation. Okay, so a convenient way of describing an element is by giving its mass number and its atomic number along with the chemical symbol for that element. Okay, so for this notation, we have X, A, Z. So, yung X natin, that is the symbol. Yung A natin, yung mass number. And Z, yung atomic number. So, we will have this as a generic symbol notation para hindi tayo malito-lito. Okay, so for example, we have this beryllium. So, beryllium 9,4, 9 as its mass number and 4 as its atomic number. Okay, mode of decay. So this is how unstable elements decay. Okay, so you have established by now, of course, that not or all of these things in this world is not permanent. They have a way of decaying. Okay, lahat naman nagdi-decay. So pati rin sa ating unstable elements. So they have these modes of decay, how they drift away from reality. Okay, so we have alpha particle emission first, and then the second we have beta particle emission. Third is the gamma radiation emission. And the fourth is about the positron emission. And the fifth is the K electron capture. Okay, so dapat nasa baba ito. So K electron capture. Okay. So in the next slides, we will differentiate these modes of decay. Pero this alpha particle that we are talking about here, alpha particle, beta particle, gamma radiation, these are also types of radiation. Ito yung sinasabi ko na ine-emit ng mga unstable natin na elements. So, when we try to have a nuclear power plant, we have an emission of radiation, and these are the radiation that I'm talking about here. The alpha particle, beta particle, and the gamma radiation. Okay? And we have counterparts. They have counter materials for this to stop it from transferring, okay, to stop it from flowing. Okay, so in the latter parts of this lecture, we will talk about this. Okay, so for now, we'll have this, how these elements, how these radioactive elements decay. Okay, so we have this mode of decay. All right. Alright, so you need to know the symbols of each of these decay. Okay, so we have here proton. So pati na rin ang mga ibang mga symbol na kailangan nyong malaman. Okay. So the proton, it has a symbol of this one, or ito. So this is a proton symbol. Ang symbol naman ng neutron natin ay ito. It has 0 charge and 1 atomic mass. Okay. Ang electron natin, it has 2 symbols. Itong E, negative 1 sa baba and 0 dito. Okay. The atomic number is negative 1. So this is also the symbol for electron for nuclear chemistry. So positron naman natin, so positively charged electron is meant by positron, and this is also, it looks like a beta din pero positively charged. the alpha particle, it has the same na symbol for helium atom. Okay, because alpha particle, it has 2 atomic number and 4 atomic mass. So sabi sa inyo, kapag ang the atomic number, it gives the identity of an element. So ito lang dapat ang gagamitin. Pero since ang atomic number ng alpha particle is 2, and that is also the same as the helium. Kaya ito rin, ganito rin ang kanyang symbol. Okay? So now, what is the difference of this electron here and then the beta here? Okay, anong pagkakaiba? Same naman sila na electron. So yung symbol na ito, it represents an electron in or from an atomic orbital. Ito yung natural. Okay? Ang symbol naman na ito, it represents an electron, although physically identical to any other electron, it comes from the nucleus. Okay? O yan yung product ng artificial na pagka-bombard, okay? Or from the nuclear reaction. So, hindi siya galing sa atomic orbital. So, may nakikita din kayo na positron, di ba? Sir, bakit may positive na electron, di ba? So, electrons are always negatively charged, di ba, sir? Di ba, yun ang sinabi nyo? Kumbaga yun tatanungin niyo sa akin, right? But, in nuclear chemistry, since these are unnatural, these are artificial, so this may be a product of being artificial, okay? So this is also called the anti-electron. Ito yung nagne-negate sa ating electron, okay? So this can happen because of artificially made na reaction, okay? So please try to remember that. Okay, so now that you know the symbols, okay, so we need to use this in balancing nuclear equation, okay? So in balancing any nuclear equation, we observe the following rules. So first rule is the conservation of mass number. Okay, so the total number of protons plus neutrons in the products and in the reactants must be the same. So dapat kung ano yung nasa reactant ay same din ang nasa product. Okay? So, the conservation of mass number. Ang mass number natin ay yung nasa ibabaw. Okay, itong 235, itong 1, itong 138, 96, and then itong 1, diba? Alright. So, to know if the equation is balanced, para malaman natin kung balance ba itong equation na ito, we need to verify it by the conservation of the mass number. Okay, yung mass number natin ulit, itong 235, itong 1, itong 138, itong 96, at itong 1. Okay? So, let's have it sa reactant muna. So, sa reactant natin, okay, burahin muna natin to. Sa reactant natin, we have 235 plus 1. That is equal to, dito sa ating product side naman, 138 plus 96 plus 2 times 1. Okay, so 2 times 1. So, tingnan natin kung pareho ba sila. So, 236 yung nasa reactant side natin, 236. Tingnan natin kung parehong 236 yan. So, that is also 236. Ibig sabihin, correct ang ating mass number. So, hindi pa natin masasabing balance yan kung mass number lang ang tama. So, we need to also observe the conservation of atomic number, yung nasa baba naman. Itong 92, itong 0, itong 55, 37 at 0. Okay? Sa reactant side natin, we have 92 plus 0. Sa product side natin, 55 plus 37 times, ay plus 2 times 0. So, they are both 92. Okay, so that equation is balanced. So, if we have that already, ibig sabihin, ang equation na yan, that is balanced. So, you need to remember that. Okay? So, let's have this example. Balance the following nuclear equation. That is, of course, we have to identify product X. Okay? So, if we are given this equation, yung X na ito daw, itong X, mga X na ito, hindi yan element. Okay? That is a variable. So, sa pagbabalance natin ng equation na to, titingnan ninyo ang periodic table ninyo. Okay? So, of course, we need to balance first ang atomic number, saka ang atomic mass, tapos titingnan natin sa periodic table kung kanino ang atomic number na yan. Okay? So, dito sa ating equation, if we are to balance okay, so number 1 muna tayo. Okay. So first, number 1, balancing the equation by the atomic number. Okay. Atomic number determines the identity of the element. So malalaman natin agad ang element kapag makita natin yan. Okay? So 84, that is equal to 82 plus x. Okay, so x kasi to, x din yan, di ba? So, hindi. Gawin natin ibang variable. Okay. Ang variable natin dyan, this is z, and this is a. Okay? So, ang variable natin ay a. Okay. So, A is equal to 2. Alright? And then, another one sa ating balancing by atomic number, atomic mass, I should say. Okay. So, that is 212 equal to 208 plus Z, A. So, this is A pala. Itong Z natin. Okay. So, sorry for that. Z. Okay. So, ang A natin, that is equal to 4. So, ang symbol natin becomes X to 4. So, alin sa periodic table natin ang may ganitong atomic number? So, titingnan ninyo. So, makikita nyo dyan, meron tayong helium 2, 4. And this is also equivalent to your alpha particle. Diba? Alpha particle din yan. So, ang answer natin for number 1, we have 212, 84, yields to 208, 82, plus 2, 4, alpha, or HE. Pareho lang din. So, this is now our answer. Okay? So, let's have another example, number 2. So, same na step, we need to balance the atomic number. We also need to balance the atomic mass. Okay. So, sa number 2 natin, number 2, balance by atomic number. So, 55 is equal to 56 plus Z. So, ang Z natin is equal to negative 1. Diba? Negative 1 siya. And balancing by atomic mass, we have 137 is equal to 137 plus A. So, A natin, that is equivalent to 0. So, ang X natin, it has an atomic number of negative 1 and atomic mass of 0. So, ano ang ibig sabihin yan? So, ano yung makikita nyo dyan? So, that's right, that is an electron. Okay? Electron yan. So, our answer becomes 137 CS55 yields to 137 56 Va plus electron. Yan. Or ito, it can be written as ganyan. Okay lang din. Okay? So, that is how you solve for this balancing nuclear equation. Okay, so we have another here. So, problems may be written like this. Okay? So, write the balance equation for each of the following process. So, carbon 11 produces a positron. So, ano ang symbol ng positron natin? We have beta, positive 1, 0, or itong electron natin na positive and 0. Diba? So, this has an equation that is C11,6 produces, ibig sabihin ay product. Diba? Produces. So, it has a product of a positron, right? So, we have positive 1, 0, or itong beta natin. Yields, ano magiging kapartner niya? Using the law of conservation of mass number and atomic number. So, kung positive 1 ito, okay, kailangan ang symbol natin for X, for example, X muna yan. So, dapat ito ay meron kang 5 and 11 lang din. So, ang problema natin, ano ba itong X na to? Okay? So, titingnan ninyo sa periodic table ninyo kung alin doon ang may atomic number na 5. Okay? So, you try to look. Okay? So, tingnan ninyo kung alin dyan. Alright, so burahin na natin ito, X na to. So, ang element na may atomic number na 5, that is boron. So, this is now our answer. Okay? Okay. So, another example here. So, example number 2 natin. So, bismuth or Bi 24183 produces beta particle. Okay? Ang beta particle natin ay okay, that is our beta particle. Okay? Okay, so this is a symbol for beta particle. But it can also be the symbol for beta is like this. Okay, so either of the two. Okay, so kung sinabi sa problem that it produces a beta particle, yes, tama. So kapag beta particle lang yan, okay, ang ibig sabihin yan, ito ang gagamitin, negatively charged. Kapag sinabing positron, ang gagamitin ay yung positively charged. Okay? So, for our answer here, we have 24183 bismuth yields to negative 1 beta plus, we have X here muna, we have 84, okay, and 241. So, you find from your periodic table kung ano tong X na ito. Alright? So, ano ang ating X dito? Kapag titinan nyo sa periodic table, itong 84 na ito. Okay, so you are right. Itong X na yan, that is a polonium. Okay, PO. Alright, so that is now our final answer. So another example here, we have the neptunium, okay, or neptune, I should say. Neptune 237 and 93 produces an alpha particle naman. Alpha particle natin is ganito, di ba? And to balance that, for example, this is X muna. Okay? So, this must be 91 para pareho silang 93, right? And this must be 233. Right? 233 para maging 237. Same sila. So, titignan nyo sa periodic table nyo itong X na ito na may atomic number na 91. So, ang X natin, ito ay protactinium, okay, or Pa. So, this is now our final answer for number 3. So, ganun lang kadali. Alright? Alright, so that now concludes the part 2 of the nuclear chemistry and energy lecture series. So stay tuned for part 3. Thank you so much.